Hello and welcome to this video on material engineering. This video in particular will be on an introduction to material engineering, and of course this is in the wider scope of mechanical engineering. So an engineer may be required to design components or products, that's a given. To do this effectively, however, an understanding of what materials are available, how they can be processed, and the properties that they hold is imperative. How well an engineering system functions is often relative to the performance or performances of these engineering materials, and an example is the efficiency of a thermal power plant, where it will be subject to predefined limits of steam temperatures and pressures of the materials. If we were able to increase the steam temperature and pressure, this would result in lower greenhouse emissions and energy costs also being lower. Such increases can only be achieved if materials are developed which can withstand these harsh conditions, and these conditions that we're referring to are the stress, high temperatures and corrosion caused by such conditions of high steam temperatures and pressures. Other examples include the strength to weight ratio of materials, and this is critical to the performance of engineering systems in the aerospace and transport sectors. And when we say transport, it's actually a wider field because it's not only for motorsports, which many people jump to the conclusion initially, but it's also for everyday motor vehicles that you do see rolling down the motorway, because in a bid to make cars more fuel efficient, thus reducing the amount of oils that we are producing, we do want lighter vehicles. However, we do still want that structural rigidity in case there is an accident, so it is a fine line between lightness but also strength, whereas if we can get the best of both worlds, well, that's an optimal condition. Next we have the fracture toughness of materials, and this is critical in applications where cracks must be tolerated. And the examples here, the most common examples, is the aerospace industry and also the nuclear industry. And they're both given why you would want them to have high fracture toughness, but in aerospace, if you are in a, say, a Boeing or an Airbus, the last thing you want is a small crack to cause the flight to be grounded, and similarly in a nuclear power plant you don't want a small crack causing an exposure. It does need to be able to still maintain structural rigidity even when it has got a fracture forming or formed. It still needs to be able to work so that it can be repaired. So that's a quick introduction to material engineering. It is literally just the tip of the iceberg. I will go into more detail, slowly but surely. And yeah, I'll try to keep the videos quite short, keep them concise so that you can just follow one after the other and not get bored. I make these more for myself, and then if it helps you guys, that's great. Feel free to leave any comments. If I do anything wrong, let me know, because this is my revision as well. And yeah, I'll see you in the next video.